functions. So for these inverse functions, it's just another method of solving or finding derivative of a function. So you see here, we are still going to use the knowledge of implicity, the one we just finished now. Differentiating y, that's going to be the y dx, and differentiating x, which is the x dx. So for example, let's say we have y is equal to sine inverse of x, and they say find the y dx. You can see it's different from saying y is equal to sine x. We know the differential of sine x is going to be cos x. So now, look at the method. It's just like you transfer this to the left hand side and left what we have as the value here, just like we change. If I have x raised to the power of minus 2 in mathematics, this is nothing but 1 over x squared. It's just like I want to apply the simple logic. Let me just give you the clue. Let's say I have a is equal to l raised to the power of minus 5, for example. So let's say I want to transfer this l to this side. I can have this one to be a is equal to, now if I have l raised to the power of minus 5, this is nothing but 1 over l raised to the power of 5. Which law do we apply here? Yeah, we apply inverse law of indices. So now if you multiply this by this, I can have a l raised to the power of 5 is equal to 1. You get that? Just like that similar thing that we want to do it here. If I do that too here, I can have sine y is equal to, what do we have left here? We have x. So I will differentiate the first side. At the same time, I will differentiate the second side, just like the way we do implicit function. So we know we have already treated the trigonometric function. Differential of sine y is going to give us what? Yeah, cos y. Recall that whenever we're differentiating y, we are going to have dy dx. Remember that? Yeah. So differential of x, what are we going to have? Differential of x is nothing but what? But 1. So when we differentiate x, we are going to have the x dx, and the x is 1. So I'm trying to look for the value of the y dx. I can make it as a subject, divide through by cos y, divide through by cos y. So if this cancel this, that means that we have dy dx is equal to 1 over cos y. So but that's not our final result. We now go back to where we have this identity. We have sine y is equal to x. So in case if you means videos for elementary mathematics, we talk about trigonometry very well. So this we can quickly apply knowledge of Pythagoras theorem. So how are we going to go with that? When we have sine is nothing but opposite socatua. Remember that? So we have car, just like an acronyms that we normally use. So if you miss the videos under the elementary mathematics for trigonometric function, just quickly check so that you call and how you can apply. But I will still break it down in a way that you can understand it more better. So I know when we have sine is a whole means the opposite, but this one I think is for the junior secondary section. So this is opposite of hypotenuse. So now if I come back here, so I know sine is nothing but opposite over hypotenuse. So now the next step, you can see if I have 2, if I have 2, I can say 2 is nothing but 2 over 1. Is there any difference? Yeah. So that means if I have x now, okay, let's put this one down full. So that means I have ordinary x now is the same thing as x over 1. So meaning the opposite is x and the hypotenuse is 1. So now here I can have the diagram like this, the right angle triangle. So recall where the angle face, I told you angle can be here or angle can be here. So where the angle face is called what? Yeah, it's called the opposite. But you see I did not use theta here. Why did I use theta? Because the angle we are talking about is not even x. The angle that we're talking about here is y. It's not all the time that it's going to be theta. It depends on the angle you are using. So the angle I'm using here is y. So this is going to be my opposite. This is going to be my adjacent as well. This is going to be my hypotenuse. So comparing the data, so meaning the opposite is x. We have the opposite to be x, hypotenuse to be 1. So do we have the adjacent? Of course, no. So we can just find the adjacent. Which method can we use to find the adjacent? If 2 sides is given and we are looking for 1 side, which method are we going to use to find that side? Yeah, we use Pythagoras. So what is the formula for Pythagoras? maybe you use m. So we know Pythagoras theorem state that the longest side squared, which is hypotenuse squared, is equal to opposite squared plus adjacent squared. You know, math have one thing. If you're solving no problem, you can enter another thing entirely. So you have to learn the previous one or the basic one so that you can be able to get the other one too as well. So from here, what we have for the hypotenuse is 1. So I have 1 squared is equal to opposite that we have here is x. That is our x squared plus I'm looking for the adjacent and we decide to use m as our m squared. So let's make our m at the subject. If I, you know, 1 squared is nothing but 1. So I have 1. This is plus x squared. So when it comes here, we have minus x squared is equal to m squared. So what can we use to cancel square? Yeah, square root of both sides. So that means our m is equal to square root of 1 minus x squared. So I can go back here now. So instead of writing m, what I get for m now is 1 minus x squared. So you now go back to your result. So you know here what we have, we said dy dx is equal to 1 over cos y. So from this diagram, we can just obtain our cos. You know, when we have cos, let's obtain cos. You know, cos is car. That is adjacent over hypotenuse. So from here, what do we get for the adjacent now? You can see we have root of 1 minus x squared, and we have hypotenuse to be 1. So this is nothing but 1 minus x squared. So now, so here I can have this to be dy dx is equal to 1 over cos. So as I explained here, cos is adjacent over hypotenuse. So from this shape, we have adjacent to be root of 1 minus x squared, hypotenuse is 1. Just like cos is adjacent over hypotenuse. So why did I put it there? Because in some cases, maybe we did not have 1 here. If you have any other value, we have evaluated the same process. So here I can have dy dx is equal to 1 all over. Adjacent from here, we have it to be root of 1 minus x squared. Hypotenuse that we have from that shape is 1. So you can see we can apply law of reciprocal here. This is nothing but 1 over square root of 1 minus x squared. So that means differential of sine inverse of x, the result is always, is it working? So differential of sine inverse of x, the result is always 1 all over root over 1 minus x squared. So if you ask to find differential of cos inverse of x, you follow the same process, the same method, but I will do one more. Let's say I want to find sec, for example, or tan. Let's find tan, for example. Let's say I want to find derivative of tan inverse of x. If you ask to do the cos, just follow the same process. So let's say, I think tan will be somewhat complicated because of identity. So let's say we have y is equal to, let's say there's a y is equal to tan inverse of x, and they say find dy dx. It's still the same process, just like the inverse I told you earlier. Change this, you know, this is nothing but and y is equal to x. You know, I've already explained the concept, right? Yeah. So now remember, even we prove this together, that when we have tan, differential of tan y, what do we have the other time? What do we have the other time? What do we get? Other trigonometric functions? Yeah, it's going to be sec square y. You know, we find that, you recall that one. So in case, if you miss that one, just go back to find the identity for tan y. Just like sine and cos have identity, tan too have identity, and we prove it together. Differential of tan is sec square y. Then we have dy dx. Then differential of x is nothing but 1. So I'm trying to find the value of dy dx. I want to make my dy dx as the subject. So divide 2 by sec square y, divide 2 by sec square y. So if this cancel this, we have dy dx is equal to 1 over sec square y. Can you see that? So now let's find identity from here. So I can have my diagram like this. This is our y, this is opposite, this is adjacent, and this is our hypotenuse. Recall, if we have tan, you know, tan is 2r. So tan is 2r. So meaning what we are talking about there is tan y is equal to opposite over adjacent. So from here, I can just make a simple comparison. with the data so that you get it more better. So we are given x. So that means I can say, since I know tan is nothing but opposite over adjacent. So compare with the one I did earlier. If you have ordinary x is nothing but x over y. So by comparison, that means our opposite is x. I can go back and put it here, x, and the adjacent is 1. So that means what we are looking for is hypotenuse. Maybe I use m, I can use m as well. Using Pythagoras theorem as usual, hypotenuse squared is equal to opposite square plus adjacent square. So what do we have for the hypotenuse? We have m, that's m squared. And what do we have for the opposite? You can see we have x, that's going to be x squared. This one is 1, I have 1 square. So now, if I have this, to make it more meaningful, if I have this, I can still write it as 1 square plus x squared. Just like I told you that when we have a plus b is nothing but what? Yeah, it's commutative. It's nothing but b plus a. So now we know when we have 1 square is nothing but 1 times 1. So that means here we have m squared is equal to 1 square, and we have 1, then plus x squared. So this is a square. What can we use to cancel square? We use square root. So if I use square root to cancel that, that means that we have m equal to square root of 1 plus x squared. So we can go here and substitute what we have for m. We have 1 plus x squared. So you now go back to your final result that we have the y dx is equal to 1 over sec square y. Sec half identity, I've mentioned that earlier. And when we are dealing with trigonometry, we say when we have sec, when we have sec, recall that when we have sec, this is nothing but 1 over cos, right? When we have sec, is nothing but 1 over cos. So let's just make a simple substitution. We know that cos is car, and car is adjacent over hypotenuse. So if I substitute the values of this one here, cos, that one is adjacent over hypotenuse. So we have 3 fractions now. Which law can we apply to change that one? Yeah, we apply law of reciprocal. This one go here. So that means sec is nothing but hypotenuse over adjacent. So now let's go back here now. So that means that we have 1 all over sec. This is my sec now. So my sec is nothing but hypotenuse over adjacent square. You can see the reason why I put square, because in the value that we have here, we have a square there. So we don't ignore that square, we put the square there. So that means here we have the y all over the x is equal to 1 all over. So let's go back here. What do we get for the hypotenuse? You can see hypotenuse we have here is a root of 1 plus x squared all over adjacent that we have is 1. So we have 1 all squared. So don't forget in maths, a square can easily cancel square root. So now this is another indices. This is nothing but 1 divided by this square that we have here. We affect this and we also affect this. So meaning root of 1 plus x squared all squared divided by 1 squared. The square that we have here, because the reason why I want to split this one into 2, because this one can be anything. So we're going to affect the 2 of them. So this is nothing but 1 over square cancel square root here. We have 1 plus x squared. Of course, 1 square is 1. So differential of tan inverse of x, the result is always 1 over 1 plus x squared. So we can have another situation whereby which maybe this is not ordinary x. Let me just give you a simple clue. It's the same thing. Or let me solve a single question from there then. Let's say, for example, we have a question like this. So instead of having ordinary x, let's say we have let's say we have an alphabet. Or, okay, let's look at this. Maybe I have y is equal to sine inverse of ax. Then they said, find the y there. So I would just be jumping step. We have already treated sine. Right, so just like the way I told you how you are going to change the inverse, this is nothing but what? This is nothing but sine y is equal to ax. You remember that? It's just like if I have ordinary x, we are going to have x left here, but now we have ax, then we are going to have ax there. So differential of sine y, and we have cos y. Differential of cos, just like the way we did it earlier, dy dx. The differential of as, of course, we are going to have a. So making it as a subject, just like the way I do it in that other one, cos y, cos y. So this cancel this, and we have dy dx is equal to a all over cos y. Then we have done that one. When we find out, what do we get the other time? We got, when we do it, when we use this shape, I think we have the cos is adjacent over hypotenuse. So from here, if you go back from here, let me just give you the simple play of that. If you go to this side, to this method, we have sine y is equal to ax. Cool. Instead of having x, we have ax now. So you can say over 1. This is your opposite, and this is your hypotenuse. So we can apply the method. We have y, opposite is going to be ax, hypotenuse is going to be 1. So that means you are looking for the adjacent. So if you do that using the method I applied earlier, or let me just find it for you. We have hypotenuse square is equal to opposite square plus adjacent square. So we have 1 square. Opposite that we have is ax squared plus let's say I use m here. That means I have m squared. So making your m just exactly of the one we treated earlier. This one I solve this, maybe you come across a problem that all we have here is not ordinary x. We have another thing. You just follow the same process. If I make my m at the subject, so that means I can have, I just want to jump a step, that is m squared can be 1 then minus ax all square. So this is a square, cancel, just like the way we do the other examples. So that what I have here is 1 minus ax all square. Can they see from there? Yeah. So now just substitute. So the y dx of that, and we can have that one to be a. So this is the cos. Cos is adjacent over hypotenuse. Adjacent over hypotenuse, that is a over, adjacent that we have here is square root of 1 minus ax all square. So this is 1. So you can see the difference. You don't need to perplex if you come across this type of problem. So that's what we have for the inverse functions.